Let's say you are a hospital and this is your database. Inside this database, you have different type of roles. You have your doctors, you have your nurses, you have your pharmacists, you have your billing administrators, you have administrators themselves. You have your application here. You want to grant your application access to your database. But then the users that are going to be accessing your database from the application are all having different roles in your organization. So you want doctors should be able to access only patients' records that are related to their role. You want to grant billing administrators access to specific PPI or PHI data from the database in order for them to be able to perform their role as billing administrators. You realize that all these test controls are supposed to be baked directly in your application. So if something happens in your application, say you want to increase access for doctors to be able to also have access to specific fields, say patients SSN, have access to patients PPI, it means that you have to come back to application to do all this modification directly in your code. Also, when we are doing AI integration, it means that the AI is going to have direct access to, which is something we are trying so hard to prevent. Never give AI direct access to your database. How do we solve this problem? We are going to break our application into 3 layers, which will be the application layer. This is where our AI application exists, which is going to be our layer 1. Then we are going to have our security layer, which is going to be layer 2. Then we are going to have our database layer, which will be layer 3. Our database layer is going to carry all our data. And then our application layer is going to only carry our business logic. Now, our security layer is where our access control is going to be. So we isolate all our security access from the application and then put it in a different layer. So if our application wants to communicate to our database, it needs to pass through the security layer. Then the security layer will now do whatever it needs to do and then grant our application layer access to our database. Our application layer will communicate to our security layer using a token. This token will contain contexts instead of permissions. This context will contain the person's identity. The person's name is Robert. The person's role, the person is a doctor. And then the reason why the person is trying to access our database, the person wants access to our patient's data. Based on this context, our security logic will now extract whatever it needs here. Oh, this is a doctor trying to access our database. And as a doctor, the person is having access to patient's data. And then access is granted for our patient's data here. The same thing happens when a billing agent or a billing administrator wants to access our database. So it will carry a context again. Now, at this time, when the context gets to our security layer will decode and know that, oh, this is a billing agent. And as a billing agent, he's not supposed to have access to patient's PHIs. All the person needs is our patient's SSN. Our application layer now communicates that to our database and then extract only our patient's SSN and then send it back to our AI layer. So you realize that with this design, our AI does not have direct access to our database. So it only have access to whatever data that it needs to communicate to a user's request. And that is what we are trying to solve. With this method, because you are not granting AI direct access to your database, your database stays safe. You don't end up giving AI unrestricted access to your database. Before we dive into our architecture, there are 2 terms that are very important for everything that we are going to be building. The first term is build time. Build time simply refers to the point at which you are actually writing the code for your system, or the configuration stage of your system, or the deployment stage of your system. So at this point, most of the times, we marry our security or access control directly into our code. So if you take a look at this particular snippet of code right now, you realize that in our Django model, we have only 2 sets of permissions. The first permission is for complete view of our patient data. Then the second one is just to view the billing information for our patient. So what happens when you now want somebody, a pharmacist, to be able to have access to our records, but then you want to redact some specific parts of our database and then give access to a pharmacist? It means that you have to come back to this particular code and add a new set of permissions because you don't want pharmacists to have access to some information that they don't need to have access to. So you have to come and write a new set of permissions for a pharmacist, and then now come down here and write a new set of functions for your pharmacist. So after doing all this in your code, you have to now go back, redeploy your system, reconfigure your system, retest your system, and just pray that nothing fails. Let's take a look at this code snippet. You realize that it has an endpoint here. This endpoint is the policy gateway that evaluates who, what, and why at the very moment a request is made into the system. This endpoint has no idea what role you are. And you also realize that we don't have any doctor view, billing view, pharmacy view, etc. because that is not needed in our invocation time system. So with invocation time, security is evaluated when a request is made into our system. And with invocation time, you don't need to redeploy or reconfigure your system when rules changes or when you make modification to permissions in your system, because those permissions or security access controls are not married into your code itself. This is how our layer one is going to be. And I'm going to be talking using Django as an example. So a user logs into your application. So the moment the user logs into your application and the person is authenticated, a session context is created for the user. Now, what does this session context contain? It's going to contain the user's identity, the user's ID, the user's role. So if the person's role is a doctor, a nurse, or a billing agent in your organization, this session context, which is a token, is going to carry all this. And then the organization that the user content belongs to. Say your organization operates in different sectors. Organization operates in the finance sector, in the manufacturing sector, and you have users across all these sectors. And then you have different organizations for them. The organization can also mean departments. Say you have your finance department, your marketing department. In a hospital instance, it can be your pharmacy department, your emergency department, etc. So this token carries all those identity. And then the reason why the user is trying to access your application. And this session context will now be passed as a JWT token. Now, you remember that all this token contains identity and not permission. And this is how our layer one is supposed to flow. Layer two is our policy gateway. So when a token arrives from our layer one, now remember that this token carries context and not permissions. This token will now be evaluated, then all the context that the token contains will be extracted. Remember that the context contains our who, our what, and our why. So this context will now be extracted from our token. Now, based on the extracted context, then our policy decisions are going to be applied. Say a billing agent again requests for specific data from the patient, and then it gets here. Our policy decision already knows that the billing agent is not supposed to have access to patient PHI, but then the billing agent needs access to our patient SSN. It will automatically do the extraction and then log the request and then return the filtered or the redacted field. The policy gateway becomes the main security system for our application. In as much as Django does its authentication, when it comes to having direct access to our database, our policy gateway does whatever is supposed to be done and then make sure that the AI does not have unrestricted access to the database. So this is how our layer 3 is going to be. The filter request will now arrive in our layer 3 for our AI tools and our data assets to process the data and then send a response to our user. So you realize that the moment the data arrives, that this does not give our AI direct access to our database. Now, the data that will also arrive will be already pre-filtered. Our AI tool does not need to perform any filtering on the data, because it has already been done. The request that will arrive will also be role appropriate. A doctor requesting for data will have access to only data that the doctor needs access to. A billing administrator will also get data that a billing administrator needs access to. A nurse will have access to only data that nurse will need access to. And then we are going to have all our data being logged and very traceable. So you know who access what, and not just that, who try to access what that they are not supposed to have access to. Everything is going to be logged. So this is the implementation of the. When you come here, you can go to the GitHub repo and you at the code itself and see how the entire implementation is done. We can also come at the documentation. So you can go to the documentation and see how the whole implementation is done. from the type of tools that we have to call data from our database. And then you can look at how the local setup is done. You can look at the prerequisites you need to actually get the system running on your local machine. You can look at the role-based access control, how it is structured. You see the access control the doctor is having. The nurses are also having a full access. You have the auditors as well. So you can basically go to the access control and then you see who is having access to what. So based on this, you can use every role to test how the system actually works. When we come back to the architecture overview, so this is how the entire implementation is done. So a user interface to how the Django backend works to AI integration, and then to where the MCP server is surfaced. This is where our security layer is surfaced. When you come to the API keys to basically it tells you the type of calls you can make, how the API key is set up, how we pass context. So when you do come here like this, it tells you that how the context is passed to our security layer. Now, one nice thing about this context is that AI does not have control to generate a context and then pass it when a tool is called. Anytime a tool is called, even when a user calls multiple at the same time, each tool call requires that the business logic part of the application sends a context to our security layer, and your AI does not have control to generate the context. The context is automatically generated when the user logs the database. So this makes manipulation of the content very safe. Anytime user requests like medical records, and then at the same time try to call another tool, get shift, pass each of these two calls are going to pass a context individually. Based on this context, then our security layer will evaluate and know that, oh, this person does not have access to call or to have access to this type of data based on the tool that is being called. So you can basically go through how the entire system is laid out, the API section. You can also see how the MCP tools that can be called. So the, the patient overview is where you use the get patient overview, the medical records tool, and then we have the patient PHI tool, we have get appointment tool, and then we have get admission. So you can go through all the entire tools that are being called. So we are going to actually do a test of our application. So just scroll down and then we come to demo accounts. We have a lot of demo accounts. Fresh. Each refresh give you a new set of demo accounts. We have nurses, we have admin, refresh again. So let's log in as a doctor, Dr. James Webb. So you see that Dr. James Webb, I already did a couple of queries with Dr. James. That is why you see the comment right here. So when you come, you log into the system, the user profile is here. Then you have quick data. So you can basically just click on this and then you get data. When you click on view more, you can get more staff data here, sample data here, and you can get more patient sample data here as well for test. Then you can actually create a new chart system here. And this is where the system tracks all the logins. And if you look at our recent activity, it shows that we logged in at 8:49. The time right now is 8:55. You can see all the tools that Dr. Webb called to get data are all recorded here as well. So what we are going to do is that we are going to create a new chart and then we can test out the system. We create a new chart. And then I'm just going to click on get patient data for Jasmine. Then I'll click on and we wait and see if the system can get us data for Jasmine. So Jasmine Watkins data is called, and you can see that it is automatically recorded here that Dr. Webb just called patient PHI and it read and access was granted. So and then you see that when we created a new chart, it's also created as here. So you can see that our audit trail is working so fine. So let's say what is the patient. Let's see if the system can get us the patient's Jasmine's appointment as well. So you can see that the system has pulled up all the appointment that is having Jasmine is having. Because a doctor can take a look at a patient's appointment, that is why we are seeing it, because a doctor is having full access to the system. That was the type of access control we gave a doctor. You can basically just test the entire system out and see. So let me just say, what is my shift? And see if I have some shift available. So you can see that the system just pulled out that, oh, here is your upcoming shift for, then it shows me my schedule as well. So you see that our system is working so well as a doctor. So I'm going to log out, just come back, try demo. Then now I'm going to log in as a receptionist. So let me log in. I'm going to create a new chat and I'll say, get me data, medical records for this. See, so you can see as your role as a receptionist, you don't have access to medical records. Contact your administrator. Let me say, what is the appointment for this? And you see that it will also be yes, okay. As a receptionist is having access to patient appointment. So it pulled out a patient appointment for the patient. So let's say, get me medical records for this. Let's see. It should also be denied as well. Then let me see my shifts as a receptionist, my shifts, and see whether it will work. Yes, so it got me my shift as well. So let me say, get me the SSN for, then I'm gonna use this patient ID to test it again and see if that is gonna work out. So your role as doesn't give you access to SSN information, so contact your administrator. You can see that our access control is enforced nicely, and as a receptionist, is not having access to some type of data, and the system is actually denying a receptionist. And the nice thing about it is that you can see that because the system tried to call a tool to access something, you see that there was an access deny recorded here in our audit trail. So it means that even if an a user tries to access a tool that they are not having access to, there will be access deny. And this access deny is not coming from our business logic application itself. It's coming from our security layer because of the context that was passed that this user Laura is a receptionist. Our security layer denied it. So all the AI is going to see is access denied. That is why you see that it will say that your role as a receptionist does not allow you to have access to SSN. Let's log out and try a new role. So we are going to log in the last as a nurse, try demo, log in as a nurse. So get me patient data for this as a nurse. The nurse is having access coming from me level of access to patients records. So a tool is being called successfully, and then you can see that the patient's medical records is pulled. You can see that the PHR access has been recorded as well successfully. So let's say, what is the patient SSN here? The nurse should be able to see a patient SSN. So let's wait and see if that can be pulled. You can see that a patient SSN is being pulled and then showed to the nurse here that is the patient's SSN. So this is how the entire system actually works. I'm going to leave a link to it in the description, and you can take a look at it. I also leave a link of the GitHub repo. You can take a look at it, and you can play around with how the entire system implementation is. It is very important that anytime you are doing AI implementation, you don't allow AI direct access to your database. The moment you allow AI to have unrestricted access to your database, say you make a simple request that get me patient SSN, the AI will pull all the records that is related to the user. It will have access to the user's first name, the address, telephone, emergency contact, the user's medical records, and then look through all this data just to filter and then show the user just the patient's SSN. But when you implement your system in a way that the AI does not have access to direct database, and anytime a user makes a specific request, there is a system in place to check the type of request that is being made. I hope you enjoyed this video. My name is Robert Yenji, and I'm a cybersecurity and AI integration specialist. See you in my next video.